Let us solve example number 5 of real numbers. So we have to prove that root 3 is an irrational number. So first of all, what do? We will have to assume that root 3 is a rational number. Okay. If it is a rational number, it can be put in the form of a by b or in fraction, while a and b are not equal to 0 and they are positive integers. Clear? Now, if a and b have any other common factor other than 1, then we can divide by the common factor, assuming that a and b are co-primes, right? Then from here, so root 3 is equal to a by b, right? So from here, I can take a value. I can get the a value as a is equal to root 3b, because b gets multiplied to the LHS. So therefore, a is equal to root 3b. So now what do? When we square both the sides, we get 3v square, because square and root gets cancelled, equal to a square. So what does this mean? This means a square is divisible by 3, and by theorem 1.38 follows that a is also divisible by 3. If a square is divisible by 3, then a is also divisible. Now in case if I assume a is equal to 3c, where 3 is some integer, then substituting a is equal to 3c in 3b square is equal to ac, what do we get? 3b square is equal to 3c the whole square, because a is 3c here. So when I substitute that here, we get 3c whole square. So from this, b square is equal to 9c square divided by 3. Now b square is equal to 9c square divided by 3. When both will be my b square, so 3 ones and 3 times, okay? So b square is equal to 3c square. So what does this mean? That this b square is divisible by 3. If b square is divisible by 3, then b is also divisible by 3, okay? So therefore, a and b have at least 3 common factors, right? But this contradicts the fact that a and b are co-primes, and this contradicts that root 3 is rational. Therefore, root 3 is irrational. That is all example number 6 of real numbers. We have to prove that 5 minus root 3 is an irrational number. So as usual, what we will do, let us assume that 5 minus root 3 is a rational number. If it is a rational number, it can be expressed in the form of a by b. Then 5 minus a by b. So what do? I shift this minus root 3 to RHS. So it becomes plus root 3, which is equal to, and shifting this a by b to the LHS, we get 5 minus a by b is equal to root 3. Now taking LCM and LHS. Okay, so here into b, here into b in the numerator. So we will get 5b minus a divided by b, which is equal to root 3. Now since a and b are integers, okay, we get 5 minus a by b is rational, right? And root 3 is irrational. But so LHS is rational, but RHS is an irrational. So but this contradicts our assumption that 5 minus root 3 is a rational number. So how do we conclude that? Because see here, this is a rational number, right? This is an irrational number. But these both are not equal, but it is given that it is equal. So therefore, this contradicts our assumption that 5 minus root 3 is rational. Therefore, we can conclude that 5 minus root 3 is an irrational number. Let us solve example number 7 of real numbers. We have to prove that 3 root 2 is an irrational number. So first of all, again, we will have to assume that 3 root 2 is a rational number. If it is a rational number, then putting in the form of a by b, what do we get? So root 2, okay, I will retain or I will isolate the root number or the irrational number to LHS and the rational to the RHS, okay, or either ways, right? So now root 2 will be equal to a by b, and this 3, when I shift to the RHS, it becomes divided, okay? So here it is multiplied, so when you shift to the other side, you should get divided. Now 3 comma a and b are the integers, isn't it? 3 comma a and b are the integers. So a by 3b is a rational number. A by 3b is rational, and root 2 is irrational. So therefore this part, LHS part, is irrational, and the RHS part is a rational number, which is not equal, but it is said that it is equal. So this contradicts our assumption that 3 root 2 is a rational number. So therefore we can conclude that 3 root 2 is an irrational number.